Hello guys, we continue now with a second example for our section 10.7. We're talking about circles in the coordinate plane, and this time the exercise goes like this. We need to prove or disprove, actually it's saying whether it's true or false, that the point 3 root 7, these are the coordinates of this point, if this point lies on the circle that is centered at the origin and contains the point 1, 4. This exercise is an opportunity to keep practicing using the equation of the circle. Just to remind you, the equation of the circle describes the different coordinates of the different points that lie on a circle that is centered at HK with a radius R. Now, based on this, and also taking into account the characteristics of the problem, let's start analyzing that, and with that we'll eventually solve the problem. So, in this case, we need to prove that this point, let's say that this is the circle that we are thinking about, this circle contains certain characteristics given in the problem. The first thing you have to take into account is that the circle is centered at the origin. All right. So when you read that, you have to remember, okay, if it is centered at the origin, it means that you already know the coordinates of the origin. In this case, this circle is centered at 0, 0. Also, they are telling me that this particular circle contains this point 1, 4. So if I were to try to locate that point 1, 4, it's somewhere over here. Let's say that you have 1 over here and 4 over here. This is point 1, 4. Okay, which is part of this circle. And this circle in particular we need to identify its equation so that it will help us confirm whether this point lies on the circle or not. With this in mind, you look, center is located at 0, 0, and this is the standard equation of a circle. Now let's try to find out the equation of this particular circle being described here. So what do we have? We have this. Let's try to write the equation of this circle in particular. It's x minus h, but h is 0, so I'm just going to keep it like that. So it's going to be x squared plus y minus k, but k is also 0, so it's going to be y squared. Do we have information about the radius? We don't. It's not given, so we are going to keep it indicated, but we can find it because this is the point. We know that point 1, 4 is part of the circle. So when you say that, it means that for this input x, the output is y, which is 4. So we can plug those in here, and we will only have r left, and we can actually find it. So as you can see, r is 1, so this is going to be 1 squared plus 4 squared equals r squared. This is 1, and this is 16, so we're going to have 17. So the thing is that we just found out that the radius of this circle is square root of 17. Now, we have all the elements we need in order for us to find out whether this point is part of this circle or not. Okay? So, pause for a moment. With the information we just obtained, now we know that the circle of this exercise is centered at 0, 0, and its radius is square root of 17. With that information, we can now obtain the equation of this particular circle. It's x squared plus y squared equals square root of 17 squared, because, the radius is a square. So this is the equation of the circle here. Now we have this equation, and with this equation, we're going to confirm whether this point is part of the circle or not. How do we do it? Well, I'm just going to make sure if when I plug in these values here, I obtain a true statement. If this statement is true, then the point will be part of the circle. If this statement is false, then that point won't be part of the circle. So here they're telling us that the x value is 3, so I'm going to plug it in here, plus, and the y value is root 7 squared. And let's see if this is true. Are they equal to each other? Let's see. So we have a 9 right here, plus square root of 7 squared is 7 equals 17. So here the big question was if these two statements are the same, and they're not. This is false. So what is the conclusion? So the conclusion in this case will be something like this, that the point 3 root 7 is not part of circle. What circle? This circle. You know, we can express the circle in terms of its equation. Okay, so this point, sorry, you know, we could try and locate it. Probably 1, 2, and 3 here, and maybe root 7 is somewhere over here, right? So this is what this is representing, okay? If this point were part of the circle, then it would be, of course, on some of these points of the circumference, but it is not. So the conclusion is that this point does not belong in the circle. And that's it. Thank you, guys.